Hello and welcome to the Simplifying Complex Fractions video. Let's just take a moment and take a look at some types of complex fractions. So basically, really a complex fraction is something that's in the form of basically a fraction over a fraction. That's basically the bottom line of what a complex fraction is. So let's take a look. We're going to be looking at some of these. I'm just going to pull some of my examples up real quick. So just very right up off the bat, I don't need the brackets here, but some examples would look like 4x over 45, so there's our top fraction, over 12x over 25. So here we have a fraction over a fraction. So let's take a look at another one, say, for example, 4 over ab minus 3 over b squared over 1 over a plus 3 over b. This is a complex fraction in that we have this numerator, which is the difference of two fractions, and the denominator, which is the difference of two fractions. So from your reading, you already know that what we're going to have to do up for the top part here is to get a common denominator, and for the bottom part here, do the common denominator. And then once we have the common denominator up top, we're going to do the subtraction, and then down here on the bottom, we'll do the addition. And then we know we're going to invert and multiply. All right? So that is another type of a complex fraction that we're going to be working with. And then my last example to identify, so x minus 3 minus 3 over x plus 3 divided by 5 over x squared minus 9 minus 2 over x minus 3. Again, this is another complex fraction. And again, the goal and the objective is to simplify. And in this case, it's kind of complex, if you will. Again, we've got different denominators. So we know we're going to have to boil it down to the red part here and put this as a fraction over a fraction. And then once we have our fraction over a fraction, we know we're going to eventually take that bottom fraction, invert, and multiply, just like we did with numbers. So that's the whole game. That's the game plan. So now we know what, by definition, a complex fraction is. We know what a complex fraction looks like. So now let's get down to business and let's start simplifying. All right, so our first example here is 4x over 45. Okay, 45 divided by 12x over 25. So here it's already in the form of a fraction over a fraction. So we know we're just going to take and rewrite the numerator as 4x over 45. And here we have to flip-flop. So 25 over 12x. And now it's just a simplifying. So notice that x cancels with x. 4 goes into 12 3 times. Notice there's a 5 here. 9 times 5 here. 25 is 5 times 5. So the 5s will cancel out. So let's just observe. Up top, I'm left with nothing but a 5. And down here on the bottom, 9 times 3, I end up with 27. So that's it. So that whole thing simplifies to something very nice. My second example here, 2x squared y divided by 3yz divided by 6 over xz. So again, we have a top fraction. We have a bottom fraction. So 2x squared y divided by 3yz. And again, we take the bottom fraction, invert, xz over 6. And now we go on our slashing spree, if we can. So y cancels with y, z cancels with z. 2 will go into 6 3 times. So let's just observe up top, we're left with an x cubed. And down on the bottom, I'm left with a 9. Nothing else to do. Our complex fraction is now simplified. Kicking it up a notch, let's take a look. 4 over AB minus 3 over B squared. All of this is over 1 over A plus 3 over B. So the idea here is first we're going to have to simplify the numerator, and then we're going to have to simplify a denominator to put it into a fraction over a fraction. So I'm going to take the numerator and just come over here for some side work, and let's just note that 4 over AB minus 3 over B squared. So again, we got to come up with an LCD. So notice that I have a B squared here. I got a B here. So one of the things that we're missing is a B. So I need to multiply the bottom here by a B. So that's going to give us a B squared. And then notice that here we got an A. Over here I don't have an A. So I need to multiply the top by an A and the top and bottom by an A. So my LCD is going to be AB squared. So again, what we multiply the bottom by to get this AB squared, we have to multiply the top by. So I hope we can see here, we're going to get 4B minus 3A all over AB squared. All right, so we got that part taken care of. We'll revisit that in just a second. So now we got 1 over A plus 3 over B. So now we're going to deal with this denominator part. So again, let's just note that our common denominator here is going to be AB. So notice that I have my A here. So if I multiply the bottom by a B, I have to multiply the top by a B. And notice over here, if I multiply the bottom by an A, then I have to multiply the top by an A. All right, so notice here I'm going to get B times 1, which is B, plus 3 times A, which is 3A, divided by, and I think we can agree that the bottom and the bottom is AB. So let's just note, coming back over here, I have my numerator, which is now rewritten as 4B minus 3A divided by, and the denominator now, which is rewritten as B plus 3A divided by, whoops, I forgot to put the denominator here, sorry. Here we have 4B minus 3A all over AB squared, and then B plus 3A divided by AB. So notice now we have our fraction over a fraction. So now this becomes 4B minus 3A all over AB squared times AB over B plus 3A. Okay, so A cancels with A, and this B gets rid of that B squared. And notice there's nothing to factor out of the top, nothing to factor down here. So we're left up top with 4B minus 3A divided by, so I have my B, and then B plus 3A. And that's the best that we can get. All right, so working with our next example, kind of similar, but a little different. All right, so we get A plus B over A divided by B plus A over B. So again, I'm going to take a look at the top over here. A plus B over A. And again, I can put that A over 1. And again, the LCD here is going to be A. So I'm missing an A here. So I multiply the bottom by an A, multiply the top by an A. So we're going to get A squared plus B divided by A. All right, so that takes care of the top part. Take a look at the bottom part. I get B plus A over B. And again, I can put my B over 1. So my common denominator here is going to be B. So if I multiply the bottom down here by B, I got to multiply the top up here by B. So here I get B times B, so B squared plus A divided by B. So now I have the bottom part as a fraction. So now I can rewrite this as a squared plus b divided by a over b squared plus a divided by b. So again, I get a squared plus b over a. So that's the first fraction. Now I got to invert the second fraction on the bottom, b over b squared plus a. And notice there's nothing, this a squared plus b, it don't factor. B squared plus a, using spoken English properly, b squared plus a, it don't factor. The a and the b, nothing can happen there. So here we get b squared plus b divided by a, b squared plus a. And ladies and gentlemen, there you have it. That's in its factored and final form. Okay. So let's take a look now at one with negative exponents. I'm going to have another one here in a little bit. In fact, I think my final example may have a... I got one here with negative exponents. Not a whole lot to do with these things, so let's take a look. X over x to the minus 1 plus 4. Okay, so let's just note that in the top part, x can be rewritten as x over 1, and in the bottom part, I get x to the minus 1 plus 4. Now, we're almost there. Notice I do have my fraction, but I'm going to take a look-see at this denominator. All right, this denominator over here, and I'm going to write x to the minus 1 plus 4, and notice that this can be rewritten, again, from your reading, from objective 3 in your reading. We can rewrite this as 1 over x plus 4. Okay, so when you have a negative exponent, you just put it in the denominator and make the exponent positive. So again, this is 4 over 1, so our common denominator is x. So if I multiply the bottom over here by x, then I'm going to get 1 plus 4x all over x. So this x over x to the minus 1 plus 4 can be re-expressed as x over 1. There's our top. And notice in the bottom we get 1 plus 4x all over x. And so now we have a fraction over a fraction. So I get x over 1 times x over 1 plus 4x. Okay. And notice that this just comes down to x squared over 1 plus 4x. And there is nothing really to factor on this one. All right, then, for our next example, example number 6, let's take a look at the following. So here we have 2 over x minus 3 minus 3 over x plus 3 divided by 5 over x squared minus 9 minus 2 over x minus 3. All right, this looks kind of a doozy, and it is. But let's see if we can't get her done. All right, so here I'd like to take a look at our numerator fraction. So let's see, we get 2 over x minus 3 minus 3 over x plus 3. And I'm kind of hoping that we can take a look, x minus 3, x plus 3. And can we agree here that the LCD is x plus 3, x minus 3. And if we can agree with that, then we have to multiply this bottom by x plus 3. So we multiply the top by x plus 3. And then over here, we have to multiply the bottom and the top both by x minus 3. So can we see that the top and the bottom, our common denominator here is x plus 3, x minus 3, and then over here, for this grouping here, we get 2x plus 6 minus, and then here we get 3x minus 9. I'm going to put those in brackets because of that minus. So this is going to be 2x plus 6, and then we can distribute the negative, minus 3x plus 9 divided by, and we can go ahead and FOIL this out, so x squared minus 9. So here 2x and that we get minus x, so 6, so we get plus 15 divided by x squared minus 9. So that's what the top part out of all of that boils down to. So I'm going to put a box around that so we can come back to that. So our next part is 5 over x squared minus 9 minus 2 over x minus 3. So let's just note that this factors to 5 x plus 3 x minus 3, okay, minus 2 over x minus 3. So I'm hoping that we can see and agree that x plus 3, x minus 3 is the common denominator. So notice if I multiply the bottom by x plus 3, I have to multiply the top by x plus 3. So let's just note that by the common denominator, we get x plus 3, x minus 9, and here we get 5 minus comes here, and then 2x plus 6. So this becomes 5 minus 2x minus 6 divided by, so here, I don't know why I put a 3 there, or a 9. That should be like that. So x squared minus 9. So let's just note we got our minus 2x. And notice that 5 minus 6 is minus 1 divided by x squared minus 9. So that takes care of the bottom part. So this whole thing here reduces to minus x plus 15 divided by x squared minus 9 divided by, so that's the top part, and then down here we got minus 2x minus 1 divided by x squared minus 9. So our top part, minus x plus 15 divided by x squared minus 9 times, now we invert this, x squared minus 9 divided by minus 2x minus 1. So these guys cancel out. So we're left with minus x plus 15 divided by minus 2x minus 1. And that's what we end up with. Boy, that was a bit of a doozy, wasn't it? All right, so as promised, I'm going to give you one more example with negative numbers, or with negative exponents. And I think after this one, we can pretty much call it the day after this one, after 18 minutes. So how about a to the minus 2 minus b to the minus 2. I promise this one is not a doozy. A to the minus 1 plus b to the minus 1. So let's just note that a to the minus 2 minus b to the minus 2. Again, when we have negative exponents, we just go 1 over a to the positive 2 minus b, or 1 over b to the second power. All right, so hopefully we can agree the least common denominator here is going to be a squared b squared. All right, So a squared, b squared. Put a squared right there, which means I have to multiply top and bottom here by b squared. So I get b squared. And notice here we multiply top and bottom by a squared. So I get minus a squared. All right, so that simplifies to that guy right there. We'll come back for a revisit. And notice that a to the minus 1 plus b to the minus 1. Again, we can rewrite this as 1 over a plus 1 over b. All right. So again, our common denominator, just like up above, instead of having a squared and b squared, we get ab. So notice here, we're missing the b, so we multiply top and bottom by b. And notice here, we're missing an a, so we can multiply top and bottom by a. All right, so notice that that's what this simplifies to. So now, we're just about done. So this top part becomes b squared minus a squared over a squared b squared divided by, and then the bottom part, b plus a divided by ab. So now we get, notice that b squared minus a squared is going to factor to a plus b, a minus b. So we get a squared b squared times, so invert. So we get ab over, and notice, oops, I got my a's and b's mixed up here. B plus a, got to be careful here. B minus a, so here we get b plus a. That should be a times right there. Looks like my squared went away. So notice that this a will cancel with that squared, and this b will cancel with that squared, and this b plus a cancels with that. So notice we're left with b minus a over ab. All right. Whew. Yeah, they can be quite of a doozy, I agree. But anyways, have a check see through this video. Go back, and if you find any oopses in here, please feel free to let me know. And outside of that, if you have any questions or any muddy points, please feel free to let me know, and then we can get everything taken care of in class. So I hope this video helps.